Jaishurjo?
Yes, sir.
Okay, so I think we will wait for another few minutes, then we will start. Okay.
Okay, sir.
Okay. Yeah. So today we'll be covering faults and porphyroclasts, thrusts, faults, bodinaj, these things. Okay. So before we start, if we have anything, yeah. Good afternoon, Velu Murugan. Murugan. Yes. So today we'll start with fold, porphyroclasts, and maybe some faults, budinaj. So the deformational features that we see in the field, okay, natural deformation features, large scale deformation features, I might say, because in the small scale also we see these things, but today we'll be mostly focusing on these large scale features. Um, Before we start, if you have anything like from the previous lectures, from the previous classes, you can ask, right? Because this is the time. Because if we move on, then it will be difficult for us to get back to these old things. So I would request the students that if you have anything uh, of the any doubt regarding the previous lectures, you may ask them now. Okay, anything. So, well, Murugan, can you hear me?
Yes, sir.
Yeah, so you are not, so I mean, I didn't notice you regularly in the class. If you have any doubt in the previous, regarding the previous lectures, you can also ask. The same thing apply to Jayashuri also. Okay.
No, sir.
Sir, uh, sir, how we can tell the about the map that it is sink from or anti from by looking at the map, contour map?
Okay, yeah. See, when you see a feature, I'll draw this. Okay, well, Murugan, you have anything? Or should I go to the, should I start sharing the screen?
No, sir.
Okay. Yeah. You can ask, okay? If you have any doubt, you can ask, all right? Anyone. Okay. So you can see the screen, right? Can you see
Yes,
the
sir.
screen? Yeah. Yeah. So suppose in the map, this is a map. This is not a real, uh, fold. So this is a 2D map, right? And you are seeing this fold, right? And so, okay, so this will be example. Let's start with the horizontal fold. Okay, so this is one fold. Can we identify this, that this is a fold?
Yes, sir. Reversal of
Yeah, so
layer.
repetition of, we may say repetition of this bedding, right?
Yes,
So uh, this is what, this is called axial plane, right? This is axial plane, the trace of the axial plane, all right? So if we plot the dip and strike of the attitude of these beds, if the like the marks are like these, so it means that this bed is dipping inward like this towards the vergence of the fold core, right? So so is this bed. So so it's dipping inward, and this bed is also dipping inward. right? So then we will say that it is synform. Okay, and if the deep of the bed is away from the core like this, right, then we say antiform. So this is the technique. Mostly people use this technique like to look for the marks. If the marks are towards the core, then we say this synform, and if it's away from the core, so we said these are antiforms. Is that clear?
Yes, sir.
So we may have like different outcrop patterns. Maybe we can have, so for example, so you don't get very planar outcrops like this, right? So you may get a fold like this also, right? In the outcrop you are seeing this, right? So this is the same bed as this one, right? So maybe like it may be going like this, and your axial plane will be somewhat like this, right? So you try to trace them by, taking like this distance will be equal to this distance, so that's how you trace the axial planes, right? It can be carved like this. Not necessarily it will be always like a plane, planar axial plane. This is uh, not a very common thing. So in the field we always get these, right? So here also you have to measure the so by seeing the contour lines. So well, suppose these are the contour lines. So from the contour lines are maybe are going like this, right? So from the contour lines you have to get the deep and strike, and from the deep and strike you have to plot them, right? So if they are you know uh, towards the fold core, then we say this is synform, and if they are outwards, like away from the core, then we call them antiform, right? Okay, so yeah, I think it's almost 6:10, so I think I'll start with today's lecture. If that's all right with everyone. Anything else? Anything else we have? Any doubt we
Sir,
have from? Yeah,
sir, contour spacing and contour interval is same or not?
yeah, they are same things. So it
Okay.
means that, yeah. So spacing means, suppose you have a contour like this, and you have a contour like this, right? Like this. So we will say that this is a more closely spaced contours, right, than this one. That means that whichever terrain you are walking, so if it has or you have like your terrain will be, the slope of the terrain will be very high, right? For this, the slope of the terrain will be very gentle. I mean, at least gentler than this one, right? In plains we will see that we don't have much contours. If you see the map of Gangetic alluvium, you won't see much contour there, right? And even if those, like if you see the Google map or any topographic maps, and when you just reach Himalaya, just you will see lots of contours are coming, so it's very high, the slope. All right.
Okay, sir.
Yeah. Okay, so I'll be starting with fold today. So we have completed up to lineation, right, in the previous class. So anything else that I am forgetting from the previous class? So Suraj actually requested, to for some material regarding this regarding this pressure shadow lineation, right? I have already shared that.
Yes, sir.
So I think we are okay with that. Are you okay with that?
शेयर किया था मतलब सर.
So I have shared that in the OneDrive folder, maybe, or maybe I have sent the mail. I don't remember.
मतलब मैंने सर अभी देखा नहीं है. और सर ये 5th वीक के बाद का सर लेक्चर जो लाइव सेशन रिकॉर्ड है सर वो भी नहीं मतलब उस पर अपलोड हुआ है.
नहीं, वो सब अपलोड हो गया है. So after, so 6th and 7th I already did upload, 6, 7 and 8. So it's there on the channel, right?
ओके सर.
Just check. Yeah, it's already there, right? So I have uploaded this 6 days ago, right? So 6th is already uploaded, and then 7 and 8 is also there. Okay. Okay, yeah. Start. Okay, so what is a fold? So in geology, we use this term a lot. There is a folding. So usually, when you see the fold, we see some wavy patterns, right, in the field that has something, or wavy layer, you might say, in the field, and that says like what is the compression direction and what is the kind of mechanism, maybe folding, maybe flexural. So these are the terms that we infer from seeing and analyzing the fold geometry in the field, right? We try to what should I say, get somewhat idea like what kind of deformation mechanism just happened there. So, but there are other features in the field that may resemble fold, right? Maybe cross stratification, maybe some erosional marks. So we have to be very careful, like while identifying those features. So fold is or will be always produced from the deformation, right? So if say for example, have you are you familiar with this cross stratification? Are you familiar with this term? Have you seen those in the field? Have you seen those cross stratification? It appears something like that: truncated top and asymptotic bottom.
यस सर.
Okay, yeah. So it appears something like that, right? Like that. So this is the flow direction, and this is a, and if some kind of deformation happened after that, then these layers will be refolded like this, right? So like the purpose of having a seeing or studying this cross stratification is that to identify the top direction, right? So when natural, in natural condition, what happens that the water is flowing on the top of it, so and it will be depositing just on the bottom layer always. So so the top will be always get truncated. So that's how we get the Younging direction, right? And when we are suppose, and if we are seeing a feature like this one, what will happen that we will be confused, right? If we cannot identify, like this appears like this is the top, right? Downwards, this is the top, but this is not the case. So this is called overturned stratification or overturned fold, something like that. So these are all, these will also be considered as folds, but these are rare cases, and mostly we consider folds which has a geometry, like suppose uh, uh, something like that, right? Some material, maybe it has another material, this is one material, and this is another material. So there is a stark competency contrast difference, right? So there will be a competency contrast, and due to that this layer will be folding, this layer will be folded, right? So from that we try to identify what kind of folds happen. Like as I was saying, we have different kinds of folds. Maybe this one, maybe this is also another kind of fold, this is also another kind of fold. Yeah, so the mainly the fold, the top and bottom surfaces of a fold is called form surfaces, which limit the extent of the fold. So the part that so always in a fold we have one inside part, that is the core. Like this is the core and this is the outwards parts, right? So surface at the outwards we call them extrados, and this is called intrados, right? It's just nomenclature, we have nothing to worry about. Just read a couple of times and you'll remember all these nomenclatures. So yeah, so this is extrados and intrados, and in between that if you have a continuous folding like this, sorry, if you have a continuous folding like this, so we are you familiar with the like in mathematics there is always a term called inflection point, right? So if you differentiate the dy dx, then the differential of this ddx of this, when it becomes 0 at that point at x and y, we call them the inflection point. Are you familiar with this? Hello?
No, sir.
Okay, so suppose this is suppose any curvature, it's increased, is it's increasing, right? It's the curvature, it's getting decreased here, and so the change of the slope of this line, that will be given by this equation, this operator ddx, right? And if it becomes 0, which means that here, like here when you are traveling from the bottom to the up, like here the curvature is increasing, right? And somewhere it's the slope is increasing, and somewhere it's maximum, then again the slope is decreasing, right? And here the slope is almost 0, and then again the slope is increasing, right? So there will be one point, so here the slope will be increasing and here the slope will be decreasing. So there is a point in between which at which the slope will neither decrease or increase, right? So that point is called inflection point. So it's a common term. So these points are called inflection points, where the slope is neither increasing or decreasing, right? So it's there. Yeah, so synform and antiform. So if the fold is say for example convex upward, like this one, so you are observing the fold um, at a, so for example a vertical surface, right? So if it's convex upward, then we call this antiform. If it's concave upward or convex downward, we call them synform, right? So this part is called synform and this part is called antiform, right? And there are different parts of folds. So this thing a little bit tricky but not so much. So for example you have a fold like this one, right? Just this one. So the point at which the, so there will be one point which is the bottommost part, right? So we call them trough, and the topmost part we call them crest. and the point where the curvature is maximum, we call them hinges, right? So the crest and hinge, it might be the same point, and it might not be the same point, right? So for example, in this case, hinge and crests, these two part of the fold, they are coinciding. But in this case, this is the topmost part, which we'll be calling crest, but the maximum curvature is somewhere here. We call them the hinges. We have one hinge, and then we have the inflection point, then we will have another hinge. This goes like this: limb, and then hinge, and then again limb, and then hinge. So within the limb, so this is the limb of this fold, and these are the limbs of this fold, right? In between that, you always have the inflection points. Yeah, so this is called the interleave angle. It's just from the inflection point you try to make or form two tangents, right? So there will be part of the limb which are more or less straight. So you just connect them, extend them, and somewhere here to measure this angle, right? So this is how we make the interleave angle. There is a purpose for measuring this interleave angle, because to get the tightness of the fold. If the interleave angle is very high, then we call them open fold, and if it's very low, then we call them isoclinal fold, closed fold. So these are different nomenclatures that we use to classify folds depending on its geometries. So we will be going through that just later part of this lecture. So, and there are other things of the fold that are very important things, which are fold axis and axial plane, right? So if this is a fold, so there is an imaginary uh, plane which is which acts as a, what should I say, mirror, right? So this part, it will be more or less symmetrical to this part, right? Or maybe not. So it depends on what angle this limb is making with this axial plane. So the plane that cuts the fold through half, say for example, so this plane will be drawn like that. You have to be equidistant from these two limbs, right? And this has to be a plane, right? So we call them axial plane. And and so to recreate this fold in a 3D space, what you can do is, if you can translate one line, like from here to all along the surfaces, we will produce this fold, right? Are we agreeing? This is how we can generate. So if this is some kind of lineation or linear feature, if we just travel this thing, translate this thing, we will be producing this fold. So this is called fold axis, right? So one imaginary line that can sit perfectly on the surface of the fold, and that will be uh, telling what is the what is that can recreate the geometry of the fold, that we call them fold axis, right? So okay, yeah, this I was saying, like if you move one line, and then you can produce the fold, right? So that will be the fold axis of this fold. Okay, so these are again different things. Okay, these are form, surface, hinge, zone, limbs. They're mostly self-explanatory. So these are fold axis. If you can translate this thing throughout, you will be ending up producing this fold. Okay, Okay, so the surface that are touching or connecting all the inflection points will be called inflection line, and the surface that will be touching all the crest and trough will be called the enveloping surface, because the fold will be always within that within those two surfaces. All right. Okay. So the axial surface trace is basically like I was telling. Suppose you have in the field, you don't see folds like this. Okay, so what we see in the field is somewhat like this. So this is one outcrop, and where you are getting this repetition of beds. So you might suspect that there might be a fold. This can be a fault, so we have to just so in the fault the pattern will be somewhat like this: 1 2 3, then again 1 2 3, like that. So this represents, this number represents one particular bed. So if you are getting like this pattern, that will not be a fold. In the fold you will get a pattern like this: 1 2 3 3 2 1, or maybe you can just use 3 ones. So 1 2 3 2 1, like that. So this will be representing a fold, and this will be representing a fault. All right. So from the field's axial surface trace is this line, which is equidistant to these two beds, right? So this is the intrados of this fold, or this limb, or this part of the fold, and this is another intrados. So the trace of the axial plane will be equidistant to these planes. All right. Yeah. Okay. So yeah, on the form surface, these are the trace. So yeah, I'll be moving on to the next page. Do you have any question from this lecture 20? Anyone?
Sir, what is
Sir,
the difference between axial plane and fold axis?
Okay, so axial plane is the plane which bisects the fold. So for example, okay, so there's some very simple image. I couldn't find that. Yeah. So this plane is the axial plane, right? So you have to connect all the hinge points, right? So these are all hinge points. You connect these hinge points, and so there will be another fold, right here there will be another fold. So in the field you don't get, usually you don't get one folds. Maybe you can get a series of folds like this one, right? Yeah. So you just connect these hinges, right? You connect these hinges and we extend this this thing in inward and outward, so you will get a plane, right?
Yes, sir.
Yeah, so this is called the axial plane, right? And the axial plane, when you can say like the when the axial plane cuts the form surface of the fold, the lineation we call them fold axis, right? We can call them fold axis, right? When the axial plane at the lineation that is produced when the axial plane is cutting the form surface, so the intersection between the form surface and the axial plane is called the fold axis. So fold axis is basically the particular line that can produce the fold if it if it translates at a particular nature, like this one, for example, this lineation, if it translates, it can produce one fold, right? So the fold axis will be, so any direction parallel to the intersection of axial plane and the form surface will be we will be calling that as a fold axis. Is it clear?
Yes, sir.
Okay. So moving on. Yeah. So folds actually can be classified with from a lot of things, like stratigraphic direction is basically yanking direction, then symmetry, the orientation of the axial plane, the plans, and all those things are there. So if you have to go through this like for repeated times, and you can practice, if you want to remember those things, you can practice by making a sketch of what kind of fold you are referring to, and alongside with it you just write the name of the fold. Say for example, if a fold that is closest upward, right, like this, it's standing upright in this position like this, so this is called antiform. If it's like this, then we call them synform, as I showed today in the map when I was showing the map thing, right? The neutral fold is neither synform or not antiform, so it's just you know and one side is just lying on one side, right? So syncline and anticline, these are different terms, right? So in the syncline, you have the younger layer inside, and in anticline, you have the younger layer outside, right? The inside, I mean in the fold core. So when you have the fold core inside, we call them syncline, right? And when you have the younger layer outside, like this is the fold core, and we have the younger layer outside, then we call them anticline, right? So what and why we need to refer to these things, because if there is a stratigraphic inversion, so in general case, if there is no stratigraphic inversion, what happens is that the older layer sits at the bottom, but the younger layer tops sits at the top, right? So this is how the stratification happens, right? So older, then younger, then more younger, like that. So when you compress this whole thing, you will end up with a a diagram or a stratigraphy somewhat of a layers folded like this, right? So where the older layer will be at the bottom and the younger will be at the top. So then we will calling them. So if we have a synclinal synform, like a syncline as well as a synform, then you can say we don't have a stratigraphic inversion. If you have anticline and antiform, then you also can say that there is no stratigraphic inversion. But if there is one inversion, I don't know where the figure is. Okay, it's somewhere. It's not here. Okay, if say for example, just drawing it for you. So So this is the younger layer, this is the older layer, right? So here you have what? Here you have syncline, right? And here you have anticline, right? So, but here you have anticline. Why do you have anticline here? Because you have the younger layer outside, right? This is the younger layer, the blue one. And here you have syncline, right? And this is anticlinal synform, right? So this is somewhat like this. This is somewhat like this. This is older layer, and this is younger layer, but this is a synform. So we will call them anticlinal synform. If we get these, or we get synclinal antiform, we will deduce that stratigraphic inversion took place. All right. So the Yang direction is opposite. So whatever other features we are observing from the field, we have to consider this thing. Okay. Yeah. So synclinarium and anticlinarium is like that. So what happens in the field, if you have a very large fold and with a huge thickness, right? Suppose you have a fold which has a much good thickness like this, right? And then you have another layer which will be having a much smaller thickness like this one, right? So what will happen? It will get folded like this, the top of it, right? It will be folded like this. So these we call them synclinarium and anticlinarium, just the term. So when it is on the so it's related with the part which is very which is syncline, we call the smaller fold synclinarium, and when it's associated with the anticline part, we call them anticlinarium, right? Yeah. So that before, yeah, so that is what I just showed you. So it's connected in the upward. So that was the original image where it is been cropped. Okay, yeah. So symmetric fold and asymmetric fold is that when the angle of the limb, so for example, this is the horizontal plane and this is the axial plane. So, and this is the angle of the limb that is making with the horizontal line. So if theta 1 is equal to theta 2, then we call them symmetric fold. If it's not, we call them asymmetric fold. It's just that, yeah. So when we are considering the Z or S, one thing we have to be very clear that we will be always considering long, short, and then long hand, right? This is the longer part, this is the shorter part, and this is again the long part. So in the long, short, long convention, if you get something that is more like a Z, we call them Z fold. And if we get a fold that has a long, short, long combination, if you have something like resembles like an S, so we call them S fold. So the term sinistral and dextral, actually we can relate to those, right? So this S, so in the counterclockwise movement, we always call them as sinistral movement, right? And the clockwise movement, we call them dextral movement. So the clockwise fold will be Z fold and the anti-clockwise fold will be S fold. So different parts of the anticlinarium and synclinarium folds, we will see that. So we have to consider what? Long, then short, then long, right? So this is more or like an Z, maybe this is, yeah, so this is Z. No, this is S, I think, yes, and this one is Z. So I'll be
सर वो वाला जो अभी सर आप डिस्कस कर रहे थे ना, उसमें सर ने वो उसको जिसको आप बता रहे थे उसको जेड बताया, लेकिन मुझे डाउट है कि वो एस है।
हाँ सर, एक्चुअली सर उल्टा बताए होंगे उसको।
हाँ सर ने उल्टा बता दिया है शायद।
हाँ हाँ, तो एक्चुअली यू हैव टू ऑलवेज okay, Sumi, thank you. So you have to always consider the long short long convention. So when you consider the long short long convention, you won't make that mistake, right? So yeah.
सर लॉन्ग शॉर्ट लॉन्ग कैसे सर? उसमें तो सर बीच में वो आएगा तो शॉर्ट लॉन्ग शॉर्ट भी तो बोल सकते हैं उसको।
No, short. So this is a convention, right? So if you consider these short long short, then it will be z, right? But this is s. So if
तो
you
सर क्या?
consider long short and long, then it will be s. But if you consider short long and short, then it will be z, right? So there has to be one convention.
सर मेरे हिसाब से जो उस उधर है वो ऐसी ही है, उसको सर कैसे भी देखेंगे सर। जो डेफिनेशन इसकी लिखी हुई है, जो बेसिक डेफिनेशन जेड और एस का लिखा है, उसके हिसाब से देखेंगे तो वो हर बार एस ही आएगा। और इधर वाला जो लिम्ब है, राइट वाला लिम्ब हमेशा एस आएगा और लेफ्ट वाला लिम्ब हमेशा जेड आएगा इस वाले केस में, डेफिनेशन
No,
के हिसाब से देखेंगे तो।
if you consider this one, so how is,
ये
suppose this is long short and long, short long and short, then this will be s, right? Short long and then short, this will be s, right?
ये नो सर, जेड है ये वाला।
No, this is z, but if you consider short long and then short limb, so short limb long limb and then short limb, then it will be z. It looks like a z. Or am I? No. Okay, so this looks like the same thing, right? Yeah, this is my bad. Um, yes, this will be S. If you consider short, long, and short, then this will be S, right? Hello?
ये सर ऐसे कह सकते हैं बट
नहीं, short, long and short लेंगे तो ये S होगा, right?
यस सर।
लेकिन अगर तुम इसको long, short और long लोगे तो ये Z होगा, right?
तो सर इसको फिर क्लासिफाई करने का फायदा ही क्या है जब दोनों ही हो सकता है तो?
नहीं, इसलिए सेम कन्वेंशन में एक्चुअली सेम कन्वेंशन अगर तुम फॉलो करोगे, तुम उसको लॉन्ग शॉर्ट एंड देन लॉन्ग लिम्ब को कंसिडर करोगे तो एक साइड पे z और एक साइड पे एक्चुअली इट्स मोर लाइक द व्हाट हैपेंस विथ लाइक सपोज यू हैव अ porphyroklast in this part of the fold and you have a porphyroklast in this part of the fold, so the rotation will be different. So just to match that rotation with the limb, that's why they did it, right? So when they just say, so this is the S part of the fold, then we will always see, okay, so we will expect the anti-clockwise movement of the porphyroklast, right? समझ में आया?
यस सर।
So